Today we're going to talk about Redis. And before we do so, let me tell you a little bit more about myself. This is a little bit more interesting than all that bio stuff. I'm a security researcher. I work for a managed security services provider. I'm an outdoor enthusiast. And I also tweet a lot, and I've got a blog and some tools available online if you're interested in seeing some of my other projects. But you're here, not for me. You're here to learn about Redis. Maybe because you're using it in your environment, or you're thinking about using it. Or maybe you already know what this talk is about because you've looked into some of the same issues that I'm going to illustrate for you all. So we're going to talk about what Redis is, what the problems are, and what you can do about it. So let me just see a show of hands. Who's actually used Redis before in their environment? OK, awesome. So have you all ever heard of Redis? OK. So it's a key value store. It's not really a database. It stores arbitrary types of data. You can store strings, lists, hashes, sorted sets, various types of data, and it does so very rapidly. So Redis is great about providing a convenient and easy way to store this data. There's not a lot of overhead, it's very fast, and it's focused on being lightweight. It's also open source, so you can go and download the source code, you can run it on a number of different platforms, and it's generally very well supported in the community in terms of different languages that you can integrate with Redis right out of the box. Now, if you do a little research on Redis, you'll find that they actually make their security model available on their website. And what's interesting about Redis is that they're very transparent that there isn't a lot of security in the product. They're solely focused on providing a high-performance, simple solution to use. They say on the website that it's only designed to be accessed by trusted users in a trusted environment. Now, how many of you think that your web farm with your web servers should be considered a trusted environment? If you're using this as a backend for a website, even if you're using this as some sort of shared memory solution, it's very difficult to say that we can trust everyone that should be accessing this service unless we go through a lot of effort to try to secure it. So Redis is command-oriented, it's not query-oriented. So a lot of the traditional issues that we have to deal with SQL injection aren't really an issue. We don't have to worry about a user potentially altering the intention of a command that's being sent because those are being handled by the low-level libraries. But unfortunately, not all of the commands are created equal. So first we've got commands that I consider safe. These are commands that only read from the data store. They typically only affect one key, so you don't have to worry about the SQL equivalent of a table scan where you're potentially paging information in and out of memory or onto disk. And so there's not going to be an issue with resource contention. These are commands like get, exists, and TTL, which are just simply returning small amounts of data. The next group of commands that we've got are what I call commands with consequences. These are commands that would allow someone to modify data that's being stored in the Redis cluster. So they allow you to set a value, delete a value, or to remove items from a queue. These only affect single keys, but they are read or write. So again, if someone was to misuse one of these, there's a potential for some malicious activity, but it's really not as bad as some of the things I'm about to show you. Next, we've got commands that are considered dangerous commands. These are commands that can infect multiple keys or the entire service, and they can impact the availability of the service if they're misused. So these are things like eval, which allows you to execute Lua code on your Redis server. That's an awesome feature, but you want to make sure that only someone that you trust is going to be using that. What about client kill, where you can go in and kill client connections to the server? So someone could go in and cut off your Apache web server that could kill the administrator's connection, or we can change the configuration of the server on the fly. So these are things that we need to keep in mind when we're rolling this service out in our environment. And now we've got commands that will ruin your weekend. These are commands that will impact the entire service if they're misused and can have real devastating consequences. Flush and flush all allow you to delete all the keys from the database. And shutdown allows you to remotely shut down the service. And this brings us to problem number 1 with Redis, and that is that there is no data control language. Every client that connects to the service can access all of those commands. They can set data, they can read data, they can delete all of your keys, and they can shut down the service. But again, this is by design. Redis is solely focused on being a high-performance solution and is not focused on providing any of these security controls that we would expect from a typical data store or database. Now, for those of you who have used Redis before, you're probably thinking, okay, well, there is this kind of hack where we can rename commands. So you can rename the shutdown command to some random string if you want to, and that's great until you actually need to use the shutdown command. And then you have to go look up what you actually renamed it to. Also, there's no way to look at that string and tell what that is actually going to do when you run it on your cluster. So if you forget the name, or if someone who's not familiar with that command tries to run it, there's no way to tell what action is going to take on that service until it runs. So this reduces the usability of the service. Now, beyond just a data control language in general, ideally, only authorized users should be able to run a shutdown command. So we should be able to say our web servers cannot shut down the service, but our network administrators can. And this brings us to problem number 2. And that's that Redis doesn't really support authentication. There's no way to differentiate between different clients that are connecting to the service. Now again, for those of you who have used Redis before, there is an auth command, but that auth command accepts a single password. And that password is shared by everyone that connects to the service. So yeah, I mean, what more can you say there? There's no multi-user support, and even if there was multi-user support, there's no ACLs. And that brings us to problem number 3. Even if you could authenticate, you wouldn't want to because there's no support for encryption. So everything is being passed in the clear to the database, and anyone can run any command that they want to remotely, and there's no way to differentiate our users or log who's doing what. But this is really okay. Redis is unique in that it is one of the few open source projects that is extremely transparent about the security model. They are upfront on the website that when you run this service, it is up to you to implement these controls. They are solely focused on performance and simplicity. And that's a real problem because if you look at all the issues we've had with SQL injection alone, with a database server that can defend itself typically, how do we expect our developers to protect this kind of solution? So what are some compensating controls? For authorization and authentication, we have the ability to rename our dangerous commands. That's great, but it reduces the usability and makes maintenance of the system harder. We've got an auth command, which is good, it's a step in the right direction, but there's no way to differentiate between users, and we're using a shared password, and it's not encrypted, so everything is passed in the clear over the wire. One solution that you see all over the place is to only run Redis locally on the host, so that you have to connect to it remotely through SSH or some other type of service. That's an easy way to secure Redis, but the problem is then you have to have everyone SSH into the box, and when they still connect to the service, their user account doesn't apply to anything that they're doing on Redis, so you still have the issue where everyone can do everything. In terms of confidentiality, they actually recommend on the website to use an SSL proxy. You can use stunnel or some other solution, but again, this is not built into the system. And if you want to encrypt the data at rest, there's no support whatsoever. So in MySQL, we have this concept of an AES encrypt function where you can encrypt data as a part of the query. We'd have to wrap the Redis libraries basically to add that kind of functionality into Redis natively. So these are some real barriers that you have to think about if you're going to be deploying Redis in your environment. If you have to comply with any kind of audit or compliance guidelines, how are you going to be able to tell an auditor that you can control who accesses the Redis installation? There's really no way to do it with the product itself. So an ideal solution that would protect Redis would encrypt all of our data at rest and in transit. We could use SSL or TLS. Ideally, it would support key value pair encryption, so we could actually encrypt the keys when they're stored at the database in case someone busts the window and pulls the hard drive out of the server. Ideally, we'd be able to authenticate our users or just support user accounts in general. And we'd support modular authentication. So if you're using LDAP, Kerberos, Active Directory, some sort of identity management solution internally, we should be able to integrate with that directly instead of trying to maintain our own authentication store. We've got to be able to log access. If you can't log who's taking what actions on the server, you're going to have a hard time cleaning up after a breach or trying to prove that the actual service itself is secure. And then being able to support rate limiting. So one of the things that's on the Redis site is that if you're using the auth command, they recommend that you pick a very strong password because Redis focuses on performance and simplicity, which means that it is very easy to brute force the server. You can send hundreds of thousands of requests to a Redis server per minute, and if you're working against a password dictionary, it's pretty easy to get through that dictionary just due to the speed of the service itself. So we need to be able to rate limit these authentication attempts against the server itself. We also want to authorize all of our users. So let's just throw away the idea of command renaming, okay? That's not a good solution. Let's implement SQL's data control language in a key value space. So being able to allow specific users to run specific commands or allow specific users to access specific keys. And let's be practical about this too. Let's not impose unnecessary performance or administrative burdens, and let's try to be compatible with native clients. So in my own work and my own experience, I use Redis a lot and kept coming into these issues, and so I went ahead and implemented a proof of concept application firewall for Redis called Sedona. And what I tried to do is implement authentication, authorization, and encryption enhancements to the Redis core without having to actually change any of the source code. Sedona is written in Python. It uses the twisted library, and it basically acts as a proxy server for all of the commands that are going into the Redis installation. So in terms of authentication, I've added a user parameter to the authentication command. So you can now specify a user and a password when you authenticate to a Redis server. We've added support for modular authentication. So if you have a backend data source like Active Directory, you can authenticate against that. In the version that's online right now, I'm using bcrypt as the authentication source. Well, to actually store the passwords themselves. And then we also want to preserve our native auth functionality. So if for some reason you've got some sort of compatibility issue where you want to use a single password, we need to support that, and that's a part of the program right now. I also added authorization. So for each one of those users, we can specify an access control list. And we can authorize those individual requests on a command or key basis. So we can say that our network administrators can run, shut down and flush, but our developers can only get and set keys. And similar to SQL with the data control language, where we can go in and allow specific users to access specific tables, we can now go in and restrict users to only access specific types of keys using regular expressions. And we can also accept and reject each one of these. So similar to an IP tables set of firewall rules, when we receive a command, it goes through a list of ACLs and then either accepts or rejects that command based on ACLs, passing them on to the Redis server or returning an error. The error and success messages that are returned are using the native Redis format. So if you're using a Python library or a Ruby library, it'll just interpret that command is coming straight from the server. There's no changes that need to be made to the client libraries in order to use it. So here's what an ACL looks like. It's in JSON, and starting at the top, you can see that when a command is first received, it's going to evaluate against that first rule, which it checks to see if the command is the set command. If it is, it'll evaluate it if it matches that key that's there, and if it matches that key, it'll accept it. So this would allow this user to write to any of the keys that start with test and then hyphen. Same thing for get. When a user tries to run that command, it will accept it. And they can also run ping and echo. But if they run anything else, it's going to reject and return an error message to the client saying that that's not authorized. So in terms of encryption, I've also added SSL support and written kind of a toy command line tool that can be used to connect to the Redis server, similar to the Redis CLI tool that comes with Redis, in order to use the encryption. So what are some of the use cases? Well, I already mentioned this, but we've got DevOps command segregation. Your ops team is going to need to be able to shut down the database. They're going to need to be able to save the database and change the configuration in case you're going into maintenance or have some need to move the server. But your developers don't need to be doing that. And developers, at the same time, need to be able to access the data on the service, but don't need to be running those commands. The use cases are also key enforcement. So we have to be able to restrict specific users to specific parts of the Redis database. And we can actually blacklist commands without having to rename them. So stop trying to write down all those weird commands that you've renamed. We can actually allow users to use the commands legitimately when they need to. So in terms of some deployment strategies, there's two ways to deploy it. It can be inline or at the edge of a trusted environment. If you're inline, it's going to be intercepting all the traffic, which is great because you get all of the security benefits. The problem is you get the performance impact of trying to authorize and parse all those packets. If you're following the Redis model and you have a trusted environment where you trust some of your users and not your other set of users, we can only intercept our untrusted traffic, which is less secure because we're still allowing people unlimited access to the data store, but there's less of a performance impact. Now, I've used the P word twice on this slide. You're probably wondering what the performance impact is, especially with a service like Redis that's solely focused on being fast and reliable. So we have to parse every packet, we have to authorize every packet, and we have to track the state for those connections since we're allowing users to actually authenticate through this proxy. And that incurs a significant performance penalty. So here I've got a graph of request transit times to the Sedona server using the Redis benchmark tool. So for those of you who are familiar with this tool, it comes with the Redis distribution and basically allows you to run a series of commands against the server to stress test it and see what kind of performance metrics you get back. On the right side, with the key, you'll see that the commands that I was running were set, get, lpush, and lpop, which are basically just adding data to the database and then requesting it back. And the way that it returns numbers is kind of interesting. I'm not sure how statistically sound the tool is because it basically returns 10 numbers and splits all those requests into different buckets. So you'll notice that each one of those dots on the graph is kind of in an arbitrary location. But what it's saying is, if you look at the x-axis and you find one of those values, with the case of all those red GET requests that are right up against the edge, that's basically saying that 95 to 98% of the GET requests that we sent to the server were responded to in about 52 milliseconds. So for those of you who have used Redis before, you're probably thinking, wow, that's really, really slow. It is. This is a proof of concept. Right now I'm the only one that's using this, and I'm abusing regular expressions, which is a part of the reason why it's so slow. But I am very confident that we can lower this number. So there are some performance implications, but there's some major added security benefits. So hopefully we can improve that in the future. Are you doing TLS on that one too? No, this is just plain text. So now I've got some demos. I'm going to show you the config files, show you how to authenticate and authorize. Cool. So first, let me show you some of these config files. So this is the actual config file for the service. You'll see that, okay. And basically it's a INI file where we can specify the Redis host that we're going to proxy connections to, and then which port we want to advertise on this host. So right now, my Redis server is running on localhost, and the Redis default port is 6379. If we're going to advertise plain text, we're going to listen on 6370. And then down here at the bottom, I've turned off SSL support right now, but that would be listening on 6371. We have required authentication, which means that you have to auth as a user once you connect to the service. And we're able to specify some stuff in here, like for instance, if you don't require authentication, we can specify the default user, which is the ACL that you get dropped into as soon as you connect to the service. So if you have someone that wants to connect to the service and maybe run the ping command, which is really not that malicious, they can do so under that ACL. To give you all an idea for what those ACLs look like, this is the config file that we're going to run in the demo. I've got two users that are specified here. The guest user, which is not allowed to do anything. Everything gets rejected. Or the test user, which once you authenticate, basically you're stuck with all those ACLs that are listed there. We can run set, get, ping, echo, and reject. The auth required, auth simple. Basically, there's a bunch of plugins that are built into the program. So if you add a plugin to the database, all you need to do is put the plugin name there, and it'll automatically start using that and pass any of the values that match auth and then whatever that value is straight into that module. So it's very easy to add support for additional authentication sources if you want to do so. So what I'm going to do first is I'm going to launch the service. So we get the firewall prompt, and you'll see right here that it's running. And first, before we connect through the Sedona service, I'm going to connect straight into the Redis database so we can run some commands and do some stuff. So connecting using the Redis CLI tool, I can go in and set any key that I want. So I can set my dog's name to Henry. I can set my dog's age to 4. And then I can go in and delete those keys. So there's nothing to prevent me from taking any kind of malicious action, like let's say flush. There we go. So there's nothing to prevent me from running those commands on the service. All those keys are gone. So let's go in and let's set some values under that test key. So let's just set test name to Will and test age to 26. Okay, so we've set some values. We can get those. That works great. Very cool. Let's also run the ping command. So if we say ping, it echoes back pong, and if we say echo hi, we get hi back. Okay, so that's some of the functionality of Redis, but there's nothing to prevent us from running any of those malicious commands that we mentioned earlier. So now we're going to exit, and we're going to change the port so we connect through the proxy. You notice that it comes right up, and let's say ping, and it says you must authenticate first. So can't run echo, and can't run shutdown. So that's great. So remember, we overrode the auth command. So I'm going to type auth test, and then I'm going to use my secret password of test, and it's going to authenticate us. So now this context is using the test username and password. I can run ping. Let's run shutdown. Not authorized to run shutdown. And let's go in and get some of those keys that we wanted to access. So I can access test name, or I can access test age, but if I try to get dog, I'm not authorized get on that specific key. So even though I can run get on some keys, I can't run them on all keys. So the advantage of this is that we don't modify the Redis core. You can still use all the great functionality that's built into Redis in terms of clustering, publish, subscribe, and the other features that you need for a high-performance data store. But if you're accessing this from an untrusted source, you get all these advantages of being able to authorize and authenticate your users. So to wrap up, I've written a tool that allows us to add additional security to Redis installations. It requires no changes to the core and allows you to secure Redis in some specific use cases with a performance penalty. And this tool is open source. It is on my GitHub page. Please go and fork it. And if you find this useful, please contribute. Because I don't really have a use case for this in my day job, but it's something that I think Redis would benefit from because it has such a large user community. So if you want, you can use this QR code to get access to the GitHub page, or you can follow me on Twitter. That's all that I have right now, though, so I want to open it up for Q&A, or we can do some more demos if you all would like to.
So for the change the semantics of talking to the server, right? So the auth command is different and stuff. So
sure.
The client libraries for like Ruby and Python and all these things, they would have to be modified to support the new semantic, right? Or like how does it fall back if it's not the right thing?
Sure. So what it does in the source code is the way that in the Redis protocol itself, you send a command and then you specify the number of arguments that are after that command, and it looks at the number of arguments to determine whether or not to use the auth command or to fail back to the old auth command itself. If you are falling back to the old auth command, it passes that straight through to the server as long as it passes the ACL. You can actually use the ACLs to like ban the auth command if you really want to. So, and that's one of the advantages of it is that you're authorizing all those commands before you get to the server, so you can really customize it however you want to. There's actually a blog post on Y Combinator this week about someone went through and showed how easy it was to add custom commands to the Redis core. If you wanted to have a command called who am I, or if you wanted to add your own data type, it's pretty trivial to do so. And so the advantage of this is that I don't have like a list of valid Redis commands. Auth is the only command that has that special stipulation. So if you modify the core to add additional functionality, it should work fine. Cool. All right. Well, if you all have any questions, I'm available. But thanks for coming in. I really appreciate it.